So in this demo, we're going to walk through the basics of creating a table in Apache Cassandra, inserting rows of data, and doing a simple SQL query to validate the information. We will talk about the importance of denormalization and the one table per one query and how it is a practical, good approach with Apache Cassandra. So again, just like before in lesson 1, we're going to be utilizing Python driver, and we're going to import our Python package here, and we're going to call it, it's called Cassandra. Now let's create a connection to the database. So we learned about this in lesson 1, so I'm just going to kind of zoom through this here. Again, creating a key space if we don't have it, but this is all should be now familiar to you. It's just the basics of setting up, getting ready, getting our session, and then executing queries. So let's imagine we'd like to start creating a music library of albums. We want to ask 2 questions of our data. 1, give me every album in my music library that was released in a given year. So any given year, I want to be able to find that. So here's an example of that query. Select star from music library where year equals 1970. And to be clear, the year can now be any year. It doesn't just have to be 1970. Any given year. Number 2, give me every album in my music library that was created by a given artist. So in this select star from artist library where artist name equals, and in this case it could be any artist that we have in our music library that we're looking for, and it's the Beatles. Because I want to do 2 different queries, I'm going to need 2 different tables that partition the data differently. My music library table will need to be by year. That's because that will become my partition key. The artist name will be my clustering column to make each primary key unique. My album library table will be by artist name, and this will be my partition key. And year will be my clustering column to make each primary key unique. More on primary keys in the next lesson and demos. If this is seeming a little confusing right now, that's okay. Just kind of go through the example with me, and we're going to focus way more on this in the rest of the lesson. So again, here's our table name, music library. Column 1 will be year, artist name, and album name will be the other columns. And our primary key, we're going to partition by year, and then we're going to have a composite key with artist name. So here's an example of our table. And then, and in the format it would be, right, partitioned by year, artist name, album name. And then here, we're going to have that same set of data. We're going to have album library, artist name, year, and album name. And then we're going to have our primary key, which is going to be partitioned by artist name, and we're going to have a composite key utilizing year. So you can see we didn't set the columns up in the same way that we did before, and that's okay, but we're going to partition by this, and then we're going to have a clustering column by year. So let's just create both tables. So we're going to create the tables just like we said. Year is an int, artist name text, and album name text with primary key. This is your focus. You want to focus on creating these tables with your primary key. So let's create this. Let's insert some data. This is all pretty straightforward, so I'm not going to go through the insert statements, but we're just inserting data. So it might have felt, as we were doing those inserts, it might have felt as you look through them. Actually, let me go back and look at them. I would just want to make it clear. So, right, we're going to be inserting data into both the music library and the album library, right? And as we saw in that graphic I showed you, that table representation, you're going to see a lot of the same data put into the different tables. So let's take an example here. We're going to insert into our query, which is query 1. And by the way, I just want to make a note here. I'm using the term query as my variable here because this is a query that I'm going to execute on my database, but this is just a variable name. This variable could be named anything. It doesn't need to be named query. It could be named Amanda. It doesn't matter what it is. It's just a variable. And I just thought it was clear that since I'm running a query, that's what I would call it. And so like for example here, this other query is called query 1, and that's going to insert into the album table versus the music table. So as we can see here, so in the first query, we're going to do 1970, the Beatles, and let it be. And then you can see here with query 1, we're going to have, again, the Beatles, 1970, and let it be. So again, it's duplicate data. So that might have felt unnatural. If I had just normalized these tables, I wouldn't have extra copies of the data. Wouldn't that be great? While that is true, remember there's no joins in Apache Cassandra. So for the benefits of high availability and scalability, you must denormalize your tables. So let's validate our data model. Let's do that select star from music library where year equals 1970. Awesome, we got back 2 results. 1970, the Beatles, Let It Be. 1970, the Carpenters, Close to You. Let's validate our data model for our album library. Again, select star from album name where artist name equals the Beatles. Awesome, we got 2 results, just what we wanted. The Beatles, 1975, Rubber Soul, and the Beatles, 1970, Let It Be. And so for the sake of the demo, I'm going to drop my tables, and we're going to shut down our connections.